A system of equations where there are some missing terms, such as this one, sometimes gives students a little bit of a problem, and I thought it would be worthwhile to talk through it. And now, they read it first of all, make sure you can read my writing. I have 2y plus 5z equals negative 38, x minus 3z equals 24, and 2x minus 3y plus 4z equals 35. The missing parts, think of them as having zeros. Now, you don't have to write this, but that's pretty much what's going on. It's like 0x plus 2y. All right, well, we normally don't write those in, but there's nothing mysterious about having gaps in the equation. It just means that there are some zero terms in it. All right, so how should we proceed? And you think, well, what variable should we eliminate? Should we eliminate x because there's only two x's? Should we eliminate y because there's only two y's? Or how about z? There are three z's. Shall we eliminate a z? And I would say we really ought to eliminate either x or y. Now, in the long run, it doesn't matter. You can choose any letter you want to eliminate, and you should be able to get the right answer. But we can save a step here by eliminating either x or y instead of the z. So, for example, think about this. If I combine these two equations together to eliminate the x, then what I have left is an equation with y and z and an equation with y and z. And so we're ready to go. Well, we have our two equations. If I were to eliminate z by combining these two equations, then I would have an equation with x and y and an equation with y and z. I would still have three letters after one elimination. But the first route I mentioned, when you eliminate x, you're down to two letters with a single elimination. So I hope that made sense. But I'm going to pick on x for this problem. And comparing these two, it looks like we should multiply this second equation by negative 2, and then we can just add it to the third equation. So if I take negative 2 times equation 2, then this gives us negative 2x, and I'll preserve the space, plus 6z equals to negative 48. Again, don't forget you've got to multiply the numbers on the right side as well. And then we're just going to add the third equation without altering it. So this gives me 2x minus 3y plus 4z equals to 35. So combine these, the x's cancel. Negative 3y plus 10z equals to negative 13. And then up here, so we've combined those two equations, and this equation already has y and z in it. This has only y and z. So you see I'm really down to solving a 2-by-2 system now. With a single elimination, we're down to a smaller problem. And looking at it, 10z with 5z, it looks like I should multiply by negative 2, this equation. So if I took negative 2 times the top equation, or negative 2 times equation 1, and I'll write it down here, then we get minus 4y minus 10z equals to positive 76. So the z's cancel, and I'm left with negative 7y equals to 63. So there we go. We've solved for y. Rather quickly, in fact. Divide by negative 7, and y is equal to negative 9. So I'm going to circle that, keep track of it. You'll notice in the book I wrote, of course I write these straight down the page as we go, and I tend to circle these sometimes. This is a way of being able to quickly find them again. All right, so there's the y variable. Now, how am I going to find z? Well, easy. I could go back to either this equation or even the top equation. Let me use the top equation. So I'm going to need to make a little room here, and I'll just erase everything except my y answer.